Investment in high-speed rail is growing around the world, and Japan has been no slouch in this department. They already have a network of rail systems all over the country, but this new $64 billion maglev train will take the cake. The high-speed railway project will divide Japan from north to south, in addition to its 9 existing Shinkansen lines. From Tokyo to Nagoya, Japan's linear Chuo Shinkansen will transport passengers 286 kilometers in 40 minutes. Superconducting magnetic levitation trains will operate on this line at a speed of about 313 miles per hour. Around 86% of the new line will be underground, requiring major tunnel construction. It is expected that the project will be completed by 2027 before construction on extending the line to Osaka begins. Approximately 40 minutes from Tokyo, Nagoya, the capital of Aichi Prefecture, will serve as an intermediate stop on the line. Despite the Japanese national authorities' resolve not to slow construction of the train, local authorities, like the prefecture of Shizuoka, have posed a few obstacles, but Japan sees this project as something symbolic of the country's determination to pick itself up after COVID-19. The bullet train will be the fastest way to get anywhere in Japan. As the world's third largest economy, it has carried more than 10 billion passengers at speeds of up to 320 kilometers per hour since the end of the Second World War. Nonetheless, Japan is now building the fastest passenger train in the world, one that will move twice as fast as bullet trains and cut journey times in half, by doing away with one fairly basic component: wheels. With magnetic levitation, these new trains will hover 10 centimeters above the ground, eliminating friction between the rails and the ground. However, the new line has been deeply controversial, grappling with delays, skyrocketing construction costs, and a ferocious environmental debate. The world awaits to see whether the project will succeed in hovering above its challenges and make a quantum leap for transportation or prove unfeasible. The Japanese know a thing or two about trains. A high-speed rail line linking Tokyo and Osaka was built by Japan in 1959, making it the first in the world. In those days, the Japanese and indeed the rest of the world remained skeptical of Japan's massive investment in rail, and many thought it would soon become obsolete as air travel and highways became more popular. The first high-speed line opened in October 1964, just in time to host Tokyo's first Olympics. In just under 4 hours, Japan's 2 biggest cities can be reached from each other. Over 100 million passengers were served by the line in less than 3 years after it opened. The same journey takes 2.5 hours on a modern bullet train. It is mind-blowing that this new train line will complete the journey in 67 minutes. Conventional bullet trains can't reach those speeds. Their wheels eventually create friction that limits their speeds. Engineers in Japan used a technology that has actually been around since the early 1900s to solve that problem: magnetic levitation, or maglev. Maglev train concepts date back to the 1960s, and the world's first, and so far only, commercial maglev line has been operating since 2004 between Shanghai's city center and its airport. Using superconducting magnets, the Central Japan Railway Company has modernized this technology. Trains can levitate higher above the tracks using magnets cooled to -269 degrees, but the trains must be moving quickly. Upon reaching 150 kilometers per hour alone, maglev kicks in and the carriage is lifted off its rubber wheels. It is then propelled forward by a set of coils on the track, one of which levitates its mass. It is now possible for carriages to travel at incredible speeds without wheels. Additionally, the trains are completely autonomous. Instead of a driver controlling them, the track does so, which makes collisions or accidents less likely, according to the manufacturer. Since 2014, construction has been underway on the Tokyo to Nagoya line, which is expected to open in 2027. Tokyo to Osaka's second extension will be built immediately thereafter and open by 2037, 10 years earlier than expected. The new rail line will cut beneath the Southern Alps, unlike the existing bullet trains whose tracks hug the Japanese coastline. The 285-kilometer-long line will have tunnels for 256 kilometers. These trains are unbelievable. Firstly, maglev trains work better when they travel in the straightest line possible, and burying beneath the mountains avoids Japan's more earthquake-prone coast. In taking this approach, JR Central has ended up digging some of the deepest tunnels in Japan's history. Several environmental concerns have been raised, particularly in Shizuoka Prefecture, where tunneling threatens the basin of the Ai River, a major source of water. The risk of disturbing the basin has been found to be low in environmental studies, but local governments have criticized these studies as insufficient and hasty. During the June 2021 election, the incumbent governor of Shizuoka even ran on a platform opposing the railway. Due to this controversy and unexpected hurdles in the construction of new stations, the project's cost has risen from $13.7 billion to a staggering $64 billion. As a result, it is one of the country's most costly megaprojects. In Japan, many are now questioning whether the new line is even worth the price. As mentioned before, high-speed rail projects are hot right now. Following the $15 billion contract signed by We Build Group to build the nation's first high-speed train, Japan has now followed suit. It's not like the Chuo Shinkansen project started yesterday. Japanese National Railways and Japan Airlines initially backed the idea, before Central Japan Railway Company took over management. Construction began in 2014 after the line received its first government approval in May 2011. Shinagawa, Tokyo's business district, and Nagoya's industrial area will be the first to be connected. Using maglev technology, the train will travel at 314 miles per hour over 178 miles in just 40 minutes. Since almost 90% of the entire route will be tunneled or underground, this section has already demonstrated the engineering and construction challenges inherent to the project. A prototype was used to create this record-breaking infrastructure. Since 1964, Japanese National Railways has been experimenting with maglev technology in an effort to develop high-speed rail. To test this innovative natural levitation technology, an 11.4-mile test track was built in Yamanashi Prefecture after the first Tokaido Shinkansen was inaugurated. The Chuo Shinkansen route was extended by 15.5 miles in 2013, according to the plan. A new train was successfully tested along the same stretch, breaking the world record for speed on manned trains. As mentioned, the railway is partially located in Nagoya. This railway will decongest the other trains that are currently in operation, reshaping Japan as it goes. By-car commuters between cities will also be converted to train travelers as a result of this project. As a result, the work will not be complete until the stretch between Nagoya and Osaka is completed. Besides being a Japanese megalopolis, Osaka is also a port city and a commercial center of national significance. The first section of the line is scheduled to be completed by 2027, but the portion reaching Osaka is not due to be completed until 2037. While planning has already begun, it will require a great deal of engineering and financial resources to connect Tokyo and Osaka by more than 311 miles. All environmental authorization protocols and checks are also being followed at this stage. High-speed rail is increasingly at the center of large-scale infrastructure plans for economic recovery, from Japan to Italy to China. We Build Group has been entrusted with the construction of a large number of lines in Italy. In the north, there is a high-speed line linking Genoa and Milan, while in the south, there is a line connecting Naples and Bari. The United States seems poised to change its transport habits after the major Texas announcement, relying less on planes and more on fast trains. According to a preliminary study published last January by the Federal Railroad Administration, Baltimore and Washington will be connected within 15 minutes. As the first segment of a line linking the U.S. capital, it would provide an essential link between the two cities to New York City. Many Americans are looking out of a high-speed train window at the future in the U.S. It has the potential to create a commutable distance between Japan's two largest cities, connecting Tokyo and Osaka on an unprecedented scale. Around the world, it's becoming increasingly coveted. Through strategically placed infrastructure, China's Pearl River Delta and Jinjinji region are being transformed into megacities. Less formally, the lines between cities in the northeastern United States, from Washington, D.C. to Boston, are blurring. In Western Europe, it's the same. The merger of major cities like this could create a powerhouse of economic activity on a scale we have never seen before. Over half a century ago, the bullet train was ridiculed by the world. As a result, Japan grew, connecting regions and sharing prosperity. After opening, Japan's economy grew from 10% the size of the US to the second largest in the world within a decade. The country will have to wait and see if this new line can propel the country to greater success.